See. Also, for the test, everybody should have their test grade already. So if you go to My Grade, you should be able to see your grade there. You should also be able to see your test and see what you did wrong and stuff like that. Like you do kind of want to look back on it because some of these problems would come back for the final. So if you got something wrong now, you kind of want to make sure that you're able to correct that mistake. So that way for the final, you don't make that same mistake. And that way in the final, you can actually get credit for those. So you do want to look over the test. You do want to go to the solution manual because I did post the solution of exam number 1. So that way you could kind of see what you did wrong. And like always, for that way you could kind of say, fix those mistakes. So that way for the final, you're not going to make those same mistakes. Because it could be a shame that you get it wrong in test number 1, and then you also get it wrong for the final. So you want to kind of show improvement and just show that you're now able to do it. So do go back and look over your exam so that way you kind of see what did you do wrong and what can you improve of it. Any question? All right. So if there's no question, we're gonna go ahead and we're gonna go ahead and start the lecture. All right, so today we're gonna do day number 7. So it's called modeling linear trend. So if you kind of remember what we did on Friday we started off where we did correlation coefficient, which the correlation coefficient tells us the strength of our linear line. So it kind of tells us how strong of a linear trend do we have. If we have a strong trend, if you remember, we either got r is equal to -1 or r is equal to +1. The -1, you kind of tell us that you have a negative linear trend. If you have a positive one, that just means you have a positive linear trend. So the only time when your r is close to 0, that's when we say we have no linear trend. All right. So today what we're going to go ahead and do, we're going to go ahead and make a model. So this linear model is going to help us make prediction for points that we don't have data set for. Let's see. All right. So we want to be able to make prediction for data set that we don't have any data set for. So what we're gonna do, we're gonna be using this model right here. So we're gonna be using y hat is equal to a plus b of x. So if you look at the a in this case is my y-intercept. If you look at the b is your slope. So what we're gonna do, we're gonna have some formula. The formula is gonna help us be able to find what A and what B is. So we're gonna have formula to help us find the slope and the y-intercept. So if you look right below, here are our formula. So that's the formula for slope. That's the formula for the y-intercept. So if you look at it, you have some variable that you should know, like S. You should know S stands for standard deviation. But the thing is, if you look at, you have S of Y and S of X. So S of X is standard deviation of the X variable. And if you have S of Y, that means this is standard deviation of the Y variable. So the subscript of X and Y does make a difference, because if you kind of remember from Friday, when we say we have like our explanatory variable and our response variable, well, S of X is saying this is a standard deviation of our explanatory variable. S of Y is a standard deviation of our response variable. So we also have X bar, but we also have Y bar. So this is the mean of the X variable. This is the mean of the Y variable. So if you see Y bar, so that means that's the mean of the Y variable. If you see X bar, that means the mean of the X variable. So if you look at the formula for the slope, it says you get R, you multiply by standard deviation of Y, and then you divide it by standard deviation of X. If you look at A is the mean of Y minus our slope multiplied by the mean of X. All right. Any question in regard to any of those two formulas? All right, so let's go ahead and let's use those two formulas. All right, so if you look at this one, it says the following table show the data for 10 random day temperature and number of ice creams sold that day in Los Angeles. So we have our temperature and we have the number of ice creams sold. So first thing we want to do, we first want to label it. So which one should be my X variable?
Temperature.
Yeah, temperature, good. So we say temperature is X. We say Y is the number of ice cream sold. So if you look at part A, it says find R, the mean and standard deviation for both variable using the calculator. So we're gonna get all of this information from class cal. So we wanna get the R value. We wanna get S of Y. We wanna get S of X. We also wanna get the mean of Y, and we also want to get the X bar. So we're gonna get all of this information from class cal. So right now we're gonna go ahead and we're gonna go ahead and transition over to class cal. So that way we could do this. All right, so the first thing I want to go ahead and do, I want you to enter a table. So let's enter a table. So we go 14, 21, 24. All right, so I enter my X value. So now let's try my Y value. Oops, that will be 52, 38. 39 and 50. All right, so here's my X1, here's my Y1. So now what we're gonna go ahead and do is we're gonna go ahead and get the R, the mean, and the standard deviation for this data set that you enter. Also, if you remember, if you press the magnifying glass, it should give you a drawing of it. So if you look at my scatter plot, you can kind of tell our R value. Should we expect a positive R or a negative R?
Positive?
Yeah, so we should expect a positive R. And if you look at our scatter plot, the scatter plot really looked like a linear line. So we should be expecting an R value that's close to 1. So let's go ahead and find this. So if you remember how to find this, you want to go to the stats button. You want to go here where it says advanced. And now if you look at it, since I have an X variable and a Y variable, you go to var stats. So on to var stats, you go X1 for L1, and then you put Y1 for L2. So if you look at it, it gave me all the information I might want. So if you look right here, it says S of X. Here, let me do annotation. Let's do spotlight. So if you look right here, if you look right here, it gives me standard deviation of X. If you look right next to it, it gives me standard deviation of Y. And if you go down, you see how it gave me X bar, which is 20.1. And if you look at it, it gave me Y bar, which is 36.6. Lastly, if you go all the way down, it gave me R, where R is 0.993356. So I'm going to go ahead and write that down. So we get R is 0.9934. If you look at standard deviation of Y, and for the standard deviation of Y, we're going to round it off to 1 decimal place. So if you look at standard deviation of Y, it says 12.46. So for that one, we're going to round it off to 12.5. So 12.5. Then we got standard deviation of X, which we're going to round it off to 5.5. Then we have the mean of Y, mean of Y. Where is that mean of Y? There you go, 36.6. And then we have the mean of X, which is 20.1. All right, so that's all we need this for. So let's go ahead and let's go back to the notes. All right. Everybody good on how I got all 5 of these things from the ClassCalc calculator? All right, so it says part B, it says use the information from above to find the slope. So our formula for the slope is B is equal to R multiplied by standard deviation of Y, all divided by standard deviation of X. So you get R is 0.9934. You get standard deviation of Y, which is 12.5. Standard deviation of X, which is 5.5. So I'm gonna go ahead and do that. So I'll do this in ClassCalc, so that way you can kind of see how to enter that into ClassCalc. And that will be our slope. So let me go right here. So for slope, we'll say 0.9934. Then you want to say multiply. And we're going to multiply this by 12.5. And then we'll say we're going to divide it by 5.5. And if you look at my slope, so my slope, I'm going to round this up to 1 decimal place. So we're going to get 2.3. So we'll say slope is equal to 2.3. And that's it. Any question on how to find the slope? All right, so I think we're gonna go ahead and do the y-intercept now. So let's go back to the notes. All right, so for the y-intercept, we say a is equal to y bar minus our slope times x bar. So let me just double check that. Yeah, there you go. All right, so we're gonna find the y-intercept. So for the y-intercept, what we want to go ahead and do is just go ahead and substitute everything in. So first thing we want is y bar. Y bar, it was 36.6. So you say 36.6 minus my slope, which we said 2.3 times our x bar. Our x bar is going to equal to 20.1. Everybody get how I got 36.6 minus 2.3 times 20.1. Okay, so let's go over to class cal and let's go ahead and make those calculations. So in class calc, we're going to say 36.6. I'm going to subtract this by 2.3, but we're going to multiply the 2.3 by 20.1. So if you look right here, we get negative 9.63. So we're also going to just round that up to one decimal place. So we'll put negative 9.6. All right, and we found our y-intercept. Here, let's take this out. We don't need that. All right, any question on the y-intercept? All right, so let's go over here. All right, so lastly, we're gonna do part D. So if you look at part D says now construct a regression straight line. So for the regression straight line, it's asking for this: y hat is equal to a plus b of x. So all we have to do is substitute what we found for A and also substitute what we found for B. So for A, we found it to be negative 9.6. So we say y hat is equal to negative 9.6 plus B, where B is 2.3. And make sure you put it next to the X. And we're done. So this is your answer. So if you look there, we got our linear regression line. Any question on the linear regression line? All right, so up next, what I'm going to do, I'm going to show you how to double check your answer using class cal. There is a way where you could get this linear regression line from class cal. So let's go ahead and let's do that. So let's go to class cal. So let's do a new line. So the new line, you want to go to stats. You want to go where it says advanced. And if you look at the very first thing where it says lin reg, so lin just stands for linear, reg just stands for regression. So this is doing a linear regression. So if you look at it, it's asking for C1 and C2. So it's just asking for what is your X variable, what is your Y variable. So for this one, it's important that you put it in that order, because if you don't put it in that order, it will give you the wrong answer. So if you remember, X1 is our X, Y1 is our Y. All right. So if you look right here, you see how it says y hat is equal to 2.25 minus 8.76. So that's our pretty much our equation. So that's our equation for our data set. So you can kind of double check this with what we got, and you can kind of see it's pretty close. All right, but that's it. So that's how you double check your answer. And also, if you look right here, it also gives you the R value. So that way you can also double check your R value. So the only reason why our equation is kind of off from this equation is because we did round our data set to one decimal place. Like if you want it to be accurate, you kind of have to use all the data set. But since we didn't use all the data set or all the pretty much decimal places, that's why we are kind of slightly off. All right, so let's go back to our notes. Any question in regard to that so far?
Sir,
All right, then. So let's go ahead and let's look at. All right. So what I want you to do, I want you to take a minute and I want you to work on this next problem. So if you look at it, it's the height and weight of these 6 kids. So for this one, which should be the x variable? Which one should be the x variable, height or weight?
Height?
Yeah, so height should be the x variable, weight should be the y variable. So if you look right here, they gave me the mean of height. So that means x bar is equal to 70. So that means y bar is equal to 155.2. That means S of x is equal to 3.03. S of y is equal to 25. R is equal to 20, oops, not 25. It's equal to 0.813. So what I want you to go ahead and do, I want you to go ahead and find the regression straight line for the data set. So I want you to find y hat is equal to a plus b of x. So take a minute and try solving that out. And once you get the answer, if you want me to double check your answer, you could just either put it in the chat board, or if you want, you can just private message me. And I'll let you know if you got it correct or if you still need to do a little bit of work. So try doing this one right now, for that way you could get some practice on it. All right, so let's try doing this problem. So some of you already submitted your answer, and most of you got it correct. Some of you, yes, got the slope correct, and the y-intercept was a little bit off. So let's go over this. So if we want to find the slope, you want to get r, which is 0.813. Multiply this by standard deviation of y. Standard deviation of y is 25. All divided by standard deviation of x, which is 3.03. So for this one, we'll do 0.813, 3 multiplied by 25 divided by 3.03. So you get 6.7 as your slope. So that's your slope. So up next, what you want to go ahead and do, find the y-intercept. So for the y-intercept, you do 155.2 minus my slope, which is 6.7, multiplied by the mean of x, which is 70. So let me go ahead and do this in class tab. For that way you can kind of see how to enter, not Spotify. Wrong share. Here we can just delete this, delete this. All right, so you do 155.2 minus 6.7. And then you multiply the 6.7 by 70. So if you look at it, you get negative 313.8. Negative 313.8. So we get y hat is equal to a, which is negative 313.8, plus b, which is 6.7 multiplied by x. And that should be your final answer for this problem. Is there any question in regard to this final problem? So if you look at the problem, it's not that difficult to do. Like the only thing is you do have to know how to get this from the calculator, but once you get it from the calculator, it should be very simple. And also just remember you want to double check your answer by just using ClassCal. Okay, yeah. And also, like whenever you're doing this problem, always make sure to label everything. So always label all of these. So that way you know exactly like how to substitute it into the formula. So that way if you have the formula right in front of you, you go like, okay, you first want to put R, which is 0.83, multiplied by standard deviation of Y, which is equal to 25. That way it will make it way more easier for you to do. All right, but that's it for that one. So you should know how to do a linear regression now. Okay. So up next, what we're gonna go ahead and do, we're gonna go ahead and do the interpretation of a slope. So for the interpretation of a slope, the interpretation of the slope is telling you how much is y increasing or decreasing if we increase the x value by 1 unit. So it is saying if I increase x by 1 unit, this is how much our value is gonna change. So to kind of show you what does that mean, we're gonna do this example. So for this example, we have the predictive value of a car and we have the age of a car in years. So for this one, we have age. Oops. We have age, which we're gonna say this is our x variable. And then we're gonna say we have y, which is the value of the car. So we have x, which is the age of the car, and we have y, which is the predicted value of the car. And we're gonna say age is in year. So it's telling us like 1 year have passed, 2 years have passed, so on and so forth. So let's look at this linear regression line. So this is, oops, sorry about that. So this is our linear regression line. All right, so let's look at our linear regression line and let's first find the slope and the y-intercept. So which number is my slope? Okay, remember the slope is always near the x value.
1,215.
Yeah, so 1,215. So we say slope is negative 1,215. Any question why 1,215 or negative 1,215 is the slope?
Yeah, can you explain how you got that?
Yeah, sure. So pretty much you just go back to, if you remember this, y hat is equal to a plus b of x. So your slope is always next to your x variable. So you go age, we said this is our x variable. So then you go like, okay, what's next to age? Well, it's a 1,215. So since negative 1,215 is right next to age, we're going to say the slope is negative 1,215. So that's how we got that the slope is negative 1,215 because we just look at what next to the x variable, age, well, 1,215 is right next to the age variable. So that's why we say that's our slope. All right, so what we're gonna go ahead and do, we're gonna go ahead and do the interpretation of this slope. So for this slope, so if you look at it, we have two variables. We have the predicted value of the car and we have the age. So if you remember the definition for the slope is saying the change of y as we increase x by 1. So let's say, what is the change of y? Well, the change of y is the change of the value of the car. So we're gonna say the value of the car will go up slash down by 1,215. All right, so for this one, we say the value of the car will go up slash down by $1,215. So the way that we decide if we should say go up or if we should say go down is by the sign of the slope. If the slope is negative, we're going to say go down. If the slope is positive, we're going to say go up. So in this case scenario, what should I say? Should I say the price is going up or should I say the price is going down?
Down.
Yeah, we're going to say the price is going down. So we're going to say the value of the car would go down by $1,215. So that's how you're going to use the sign of the slope. If the sign is negative, you're going to say it's going down or you can say it's decreasing. If the sign is positive, you're going to say it's increasing or is it going up. So we're going to say the value of the car would go down by $1,215 for, for every additional year. That should be that passes. All right, so the interpretation of the slope will say the value of the car would go down by $1,215 for every additional year that passes. And that's your interpretation of the slope. Any question in regard to that interpretation? All right, so let's go down. So we're going to interpret this slope now. So for this slope, what we have the weight of the child, and we have the height of the child. All right. So for this one, which one's my x variable? The weight of the child or the height of the child?
Height.
Yeah, so height. So we say x is the height variable. So that means y is the weight variable. All right. So now that I know x is equal to height and weight is equal to w, which one is my slope? Would negative 314 be my slope, or 6.7 would that be my slope?
6.7.
Good job. Yeah, 6.7 is the slope. Like an easy way to kind of look at this, like you always look at which number is next to something. The number that's next to something, that will be your slope. Because if you look at the 314, it's by itself. So essentially it's a loner. So the loner will always be the y-intercept. The one attached to the variable will always be your slope. All right, so let's interpret this slope. So for this one, we'll say the weight of a child will go up / down by 6.7. All right, so for this one, weight is in pound and height is in inches. So just kind of know that. So for this one, we're gonna say the weight of a child will go up / down by 6.7 pounds. Because that's what the y-intercept, well, sorry, that's what the y variable is the weight. So we're gonna say the weight is changing by 6.7 pounds. So first thing we wanna decide if we want to put up or if we want to put down. So for this one, what should I say? Should I say the weight is going up or should I say the weight is going down?
Going up.
Yeah, it's going up. And the reason why I know, because my slope is positive. So we're going to say the weight is going up. And we'll say it's going up by 6.7 pounds for every additional inch. So like each additional inch that this child add on or the student add on, it essentially mean like they should be gaining 6.7 pounds. So for each inch that their height is growing, we're gonna say that that's gonna transfer over that they should gain 6.7 pounds. All right, but that's it for that second example. Any question for that second example?
No.
All right. So now we're gonna go ahead and make prediction. So the whole point of the linear model is we want to use it to be able to make prediction. So we want to make prediction for data set that we don't have. So for part A, if you look at it, it says find the predicted weight for someone that is 67 inches tall. So for 67 inches tall, does that reflect the height or does that reflect the weight of the student?
The height.
The height. So where do I want to put that? So do I want to put it right here or should I put it right here? So should I put it right here in A or should I put it right here in B?
B.
You want to put it in B. So what we're going to do to make a prediction for the weight, we're going to say negative 314 plus 6.7. And you want to substitute 67 in for height. So instead of putting the height, you're gonna put 67. Everybody good with that so far?
Yes. Sir.
So let me go over to class calc, and we're gonna go ahead and do this. Yeah. So in class calc, all we have to do, we have to say negative 314. So you say negative 314 plus 6.7 multiplied by 67. All right, so we got that value. Oops. All right, everybody good on 134.9? And also just remember guys, you do want to practice on class calc because you don't want to be making like mistake on the test because you haven't practiced on class calc. Because class calc is pretty easy to use. But like with anything, if you don't practice on it, like you're not going to be able to do well on the test. But just practice on class calc for that way you can kind of get used to it. All right, so for part B says find the predicted weight for someone that is 71 inches tall. So if somebody is 71 inches tall, all you have to do instead of putting 67, you're going to replace that with 71 inches. So what should somebody weigh if they are 71 inches tall? And if you want, you can put this in the chat, or if you want, just yell out the answer. Cool, good job. So you get 161.7. And that's it. So if somebody is 71 inches tall, we're going to predict that their height or that their weight should be 161.7. All right. So one thing you should kind of know about the prediction are not always going to be 100% correct, but it should kind of give you the ballpark figure of what it should be. Kind of think about it like if you ever like look into buying a car or if you ever bought a car, like if you ever go to like Kelley Blue Book value, the Kelley Blue Book value is making a prediction about what you should pay for a car. But you kind of know for the prediction, it's not always going to be 100% correct. Sometimes you're going to pay more for the car or sometimes you'll pay less for the car. But the prediction is kind of like your baseline of what you should be paying for. Because you don't want to like pay for a car, pay like 10,000 for a car that only worth 5,000. So the the predictive model, which this is kind of going to tell you a ballpark figure of what it should be. Because most likely it's not going to be exactly 161.7, but it should be somewhere roughly close to that value. All right, so let's scroll on down. All right. So the last thing we're going to get into is something called extrapolation. So extrapolation is when we go far beyond our data set. So when we do extrapolation, it just means like we have our data set and our data set is only to make prediction for value that are from x is equal to 0 to x is equal to 20. But we try to go beyond that. So to kind of demonstrate that, we're going to do this problem. So if you look at it, we're still using the model to make a prediction about the cost of a car. But for this one, what I want you to do, I want you to make a prediction on how much should a car cost if it's 40 years old. So make that prediction right now for me. Oh, you want to check that again? Should it be that high? Think you might have forgotten to do a negative. Cool. All right, so let's do this one. So if you do predicted value is equal to 21,375 minus 1215 times 40. Let's do this in class count. So we go graphing. So we're going to do 21,375 minus 1215. And you just multiply this by 40. So if you got negative 27,225, you got the correct answer. All right. So that's the value. So it's saying if a car is 40-year-old, the predicted value is negative 27,225. Does that answer make sense?
Yes.
So you're telling me that a car should value negative 27,000? That's fine?
My bad.
No, that's fine. So yeah, so if you look at this, this doesn't really make sense because what this means, like, so here's the seller. So the seller has this car. We'll put some wheels on it. So since this car is 40-year-old, it has an antenna and all those good stuff. So here's the seller. And then we have our buyer. So what the negative 27,225 says is saying that like the person selling the car, they should give the buyer $27,225 plus they also get the car. Oops. They want that hood. Whoa. And they get the car. Does that make sense at all?
Nope.
No, it doesn't really make sense because after a while, like the value of the car should just become zero. Because after a while, the car should just go like the car is worthless, and the value of the car should be zero. So that what we mean by extrapolation when we're trying to make a prediction of something that just go beyond our data set. Because for our data set, it's only good for a certain range of number. But for this one, since it's going beyond it, since it's going 40 year, that way it's giving us a value that really doesn't make sense because like eventually the car should be worth nothing and we should leave it as that. All right, but that's it for today's notes. Any question in regard to today's notes? Wait, all right. So let me kind of show you where everything will be at. So in case you did come in late or anything, you know where to go. All right. So if you miss anything that I wrote down for the lecture notes, what you want to do, you want to go right here where it says week 3. And right here, if you go to week 3 note solution, well, that's where I'm going to put them right now. So if you did miss anything about the lecture note, if you want to go back to my lecture note, that's where I'll upload it. Let's go back to content. Cool. If you want to see the YouTube video, so if you came in late, if you want to catch the beginning, like 10 minutes that you missed, that's where I'm going to put that. Also, you have a quiz today, so let me show you where to go for the quiz. So for the quiz, pretty much, if you look at all of these, we're all done with all of these because that was for exam number 1. Now we're moving on to these, which is for exam number 2. So for quizzes, we're gonna be over here. So you're gonna be doing quiz number 6 today. So quiz number 6 is gonna be for the, what do you call it? Quiz number 6 is going to be for the correlation coefficient, so finding R. So that's going to be for today. So if you do for today quiz, you just want to go here and it should be open from once the class ends at 11:30 all the way till the end, I think till 10 p.m. So whenever you have a chance, do the quiz. And I gave you 30 minutes for the quiz. So for this one, hopefully you should have enough time to upload it, but if you don't have enough time to upload it, just email it to me, to my email, and I'll still give you credit for it. All right, so you also now have homework. So for the homework, you wanna go right here where it says linear regression and correlation. You wanna go right here where it says homework. And for your new homework, it's gonna be under regression. So correlation coefficient, that was a homework for Friday. So this is going to be your new homework. So if you already finished all the correlation coefficient, you can now move on to regression and you can now be able to do regression homework. Also, if you finish regression homework, you could technically already move on to 2 variable statistics. It's exactly the same thing. All right. Cool. All right. And also for the activity, so we already did, or you should have already done activity number 7. So we should be in on activity number 8. So right now, once I break you up into your breakout room, you should start working on activity number 8. Is there any question before I break you up into your breakout room? All right, sweet. So let me get activity number 8 over here. All right, so you should start working on activity number 8. So let me break you up into your breakout room and I'll start jumping around for that way I can help you with any question you might have. So let's break them up into. All right, so I'm gonna open up the room. So you should be getting an invitation right now. So once you get the invitation, just accept it and go to your room. Hey guys, so how are we doing with the activity?
Right now I'm just inputting the table.
Okay, cool. Any questions so far for any of that?
No, thank you.
Okay. Well, if you do have questions, yes, send me a private chat, and that way I'll jump back into this room.
Okay, thank you.